Hey ANPers, this is Dr. Jones checking in. This is ANP1, Lecture Test 4, Video 11, covering page 12 of the note set. I do have a guest with me. I've got a Pepper the Pupper in my lap. I was sitting at the desk and I heard this one tiny little scratch at the door. And by the time I found her, she'd already gone back to my daughter's room, but she was by herself. And so she came to me and now she's sitting in my lap. Yeah, she's a cutie. She hasn't been trimmed lately, and so she's growing like straight out in all directions like a dandelion fluff. Yeah, she's like a fluff. In fact, we call her the floof. Okay. Enough about the dog. Let's talk about the note set. All right. So the length-tension relationship can be explained with this chart, which granted looks a little odd, but follow me, we'll get there. So if the zone of overlap is very small, so here we have a small zone of overlap, so this region-ish on the chart. Oh, she got it. So here's floof. Look at that face. Look at that face. She's all floof. Yeah, she needs a little haircut. Okay, down we go. I think Papa just got home. So, when there's very little zone of overlap, very little overlap in the zone of overlap, you can produce a little tension because you recall that it's the pivoting cross bridges that create the muscle tension. And when there's so little overlap, there are, oh no, she went out of the room. Just a second. Okay, come on. I'm recording, but the dog heard you. Sorry, dog wanted to see the big man. All right, so when there's very little overlap, you can't produce much tension because you can't have very many pivoting cross bridges at the same time, and it's the pivoting cross bridges that pull those Z-lines closer together that create the muscle tension. So when the thick filaments are touching the Z-line, like you see right here, which is this part of the chart, you can't make any tension because they're already as far as they go and they can't go anywhere, so you can't create any tension. So zero tension. And describe the sarcomere length that produces the most tension, where you have a large zone of overlap, but the thin filaments do not cross the M line. And so you can see with the tension, percent of maximum, this little range here is your highest tension. And here's 50%. So this is where you've got a large zone of overlap, but you have not crossed the midline, is where you get the most tension, which makes sense because everyone knows that you get most strength in the belly of the muscle. When you're out here, you've got less strength. When you're up here, you can create less tension. It's right in the middle of the movement, the belly of the muscle, which is where you'll have this scenario and the most tension. Okay, so it's all about the amount of overlap in the zone of overlap. All right, let's get my head out of the way here. Okay, so twitch, which the more you say the word twitch, the worse it gets. Twitch. Twitch. It's just such a weird word. It's awkward, like the word awkward. How are there two W's in the word awkward? Right? Okay. So the single stimulation of a single muscle fiber produces a single contraction called a, let's go back to red. Red shows up better. Twitch. Now, in an eye muscle, the twitch can last, be as fast as 7.5 milliseconds, But in the soleus, the leg muscle behind the gastrocnemius, which is one of your postural muscles, it keeps you upright when you're standing, they last like 100 milliseconds. So the duration of a contraction can be extended by repeated stimulation, and a sustained contraction produces more tension than a single twitch. All conscious and subconscious movements are sustained muscular contractions. So a single twitch, like you see in this picture, pretty much only happens in the lab. So the twitch is the single stimulus contraction relaxation sequence in a muscle fiber. And what was a muscle fiber? A muscle cell. Okay. So the latent period is this part here, between the stimulus and the beginning of the contraction. And in this picture, it's about 2 milliseconds. And this is the time it takes for the muscle action potential to propagate down the entire sarcolemma inside every T-tubule, for every sarcoplasmic reticulum to release calcium, for the calcium to bind to the troponin to change shape, pulling the tropomyosin off of the active sites on actin, and then the myosin binds, and then once it pivots, then we are in the contraction phase. Okay, I hate drawing with a mouse. It's that part. That was terrible. Okay, we'll put a box around it so that it made it worse. Okay. The contraction phase lasts about 15 milliseconds in this picture, and it's the tension increases to peak. The top is the peak, just like a mountain peak, except it's P-E-A-K. Okay. And this is where you have the cross bridge cycling, where you have the pivoting cross bridges. And then 3 is the relaxation phase, which in this example is about 25 milliseconds. And it's where the tension decreases to resting, and so it takes longer to pump that calcium out of the sarcoplasm than to dump the calcium into the sarcoplasm. And this is the time it takes for the cross bridges to detach. Okay. Now I'll cover one of these for this page. Now it's put me right in the middle of here of the next picture because we're not looking at that. Okay, Treppe, which I'm told is the German word for steps, and they do kind of step up in tension each time. And in Treppe, a skeletal muscle is stimulated again after the previous relaxation phase has ended. So we had a little latent phase, a contraction phase, a relaxation phase, back down to 0 tension, and then stimulated again and again after it's gotten back down to 0 tension. And you do see an increase in tension each time, and again they believe that believe that this is because some of the calcium is still in the sarcoplasm, creating stronger contractions each time. So each contraction will have a slightly higher tension than the previous contraction up to a point, and that point is a maximum tension in Treppe. That's how that works. And looks like the frequency here, the frequency is how often, will be less than 50 stimulations per second. Like 30 to 50 stimulations per second will be Treppe. So this has been A&P 1 lecture test for video 11 on page 12. Thank you as always for tuning in. The education must go on. Dr. J.